Okay. Hello everyone. This is Justin from Blockchain HKU, and today we are very glad to have Kathy, HKU alumni, who is also a PhD student and a governor of ZK DAO at Harmony, to join us today to talk about NFT and smart contracts. So without further ado, let's start the workshop.
Hey, thank you, Justin, and welcome everyone. We will get to know what is ZKU a little bit, but before, of course, as promised today, this workshop is about how to create your own NFT. So I am assuming that everyone who is here should be a programmer, at least maybe proficient in one programming language. Okay, and so today is about a little bit of kind of Solidity 101. So hopefully by creating a NFT contract, we will be able to kind of go through the key skills, the basic skills of how to write a smart contract in Solidity. So this is basically today's agenda. We will start off with, of course, just like any programming language, a hello world exercise. And then we'll go through some basics of Solidity. So some Solidity 101, some things that is key, that is quite different from other languages that you should pay attention to. And then we will go through how to just quickly create an NFT contract with different functionalities. And then we'll also talk about an opportunity that we would like to offer you to continue to develop your skills in Web3. So without further ado, let's start our content today. Well, a little bit of introduction of myself, as Justin also introduced me already. So just to highlight a little bit is that I am teaching at a course that's called Zero Knowledge University. Partly where as an educational initiative that we'll mention a little bit more at the end of the program. I also regularly speak at different public workshops or corporate training on the topics of blockchain, Web3, metaverse, machine learning, all about those stuff. So you might also see kind of my public workshops around the city as well. And one thing that I really want to highlight is that I actually started Solidity programming not long ago. So today is April 2022. I actually started in late 2021, to be exact, kind of November, December-ish. So but of course, I originally know how to program. So it's a little bit of kind of transition into Solidity. But just want to highlight that it's actually not that difficult. So the first thing that we're going to do is just get started to programming. The first thing we will have to know is the kind of general contract structure of how each smart contract on Solidity will look like. Okay, we'll talk a little bit more about what it is in a bit, but just to let you know that every single smart contract on the blockchain looks something like this. Okay, so it basically specifies a Solidity version, and then it has a contract name, and then it has some function that does something. You know, smart contract is really just a fancy name for computer programs that run on blockchain. Okay, so anything that you can think of in normal programming, something like conditional logic, like if else, while loop, for loop, everything is almost the same. The most similar language I would say would be JavaScript, but again, there is some key differences that we will talk about in a bit. Okay, and so this is basically how every single contract will look like. So you have a contract name, or in other words, the program name or the name of the app. And then you have some functions that perform different functionality in the contract. And today, you don't need to install anything onto your computer, luckily. So we don't have to spend like 30 minutes of the 90 minutes just wasting time on installation or environment setup. Today, we're using something that is in your web browser, an open source IDE that allows you to write, compile, debug, and just deploy Solidity code all in your web browser. So this is a tool that's called Remix IDE. So let me send the link in the chat for everyone. Before I move on. Okay, so for some of the materials today, I have actually compiled a gist that I will also release at the end of the session. But meanwhile, I'm going to put all the links that you need in the chat box in Zoom. Okay, so this is where we are going to go for the IDE. So now let's all move on over there and let's take a look at how it looks like. Okay, so if you enter the website that I have put in the Zoom chat, this should be what you get. So as we are programming, feel free to put any questions in the public chat box so that I can see. Hopefully I can get to it as soon as possible. If you are getting any errors, definitely send it in the chat so that I can see as well. Okay, so well, let's take a look at what are the different features or parts, components that we have on this browser here. So we have something that looks like some folders on the left-hand side with some files that is already in there. So Solidity is a programming language, just like any other programming language. So unfortunately, today we're really focusing on hopefully programmers that are already know one single programming language, but I think the content is still easy enough for you to follow along. But unfortunately, we don't have too much time to go into like what it is. But you can think of it as basically it's a programming language that the blockchain use. Just like maybe you have heard of other programming language like Python, JavaScript, C. So those are the most common programming language in the Web 2.0 era. And now as we move into blockchain, the language we use is Solidity. Okay, so this is the browser that we have on IDE, on Remix. And that is some file structure that we have here. So you can see there's several folders, contracts, tasks, scripts. And then this is the first tab. If you click on the third tab, okay, so the third tab with the S icon, let me zoom in a little bit more. And let me use a spotlight. Okay, the third tab right here, this is where the compiler is. So compiler basically compiles your contract into something that the blockchain could understand. So it will be a series of numbers that that's called bytecode that will be eventually uploaded to the blockchain. So what is uploaded onto the blockchain, it doesn't actually look like the contract that we wrote. Okay, and then there's also one more tab that we will pay attention to today, which is the fourth tab on the left-hand side. And that is the deployment and running transactions. So for the most of the session today, we'll be using what Remix has already provided us, which is a virtual machine that they have hosted so that we can just simulate how it will look like on the blockchain. Okay, but there are also other ways that we can actually deploy the contract into a real blockchain, which I will demonstrate at the end of the session. But I don't encourage you to try to do it within today because you risk, paying like real gas fee and also using real tokens. So what we will be practicing today will be mostly using the virtual machine, but then I will also demonstrate how to use, say, your MetaMask wallet or any other blockchain wallet to deploy the contract onto some chain. So now we will go through the process of basically deploying a hello world contract onto the virtual machine. So let's go back to the first tab here with the two kind of page icon, which is where our files are. And then we're going to open the first contract that is already on the IDE for us. So the one_storage.so. Okay, so let me zoom out a little bit so that I can see the contract. So this is probably the simplest contract, one of the simplest contract you can have possible. Okay, it's a very simple program that its sole functionality is to store and retrieve values in a variable. And then it has something called a number. We'll talk about each part of what it means in a bit. So there's a variable that's called a number, and then it has two functions in this contract. One function is to store a number, and the other function to retrieve the number. Okay, so we don't have to make any modification to this contract. We just want to deploy it as it is, just to practice the flow of deploying a contract. So with this open, so don't close it up. With this open, we're going to go to the tab again with a little green check mark on the left-hand side. So Solidity compiler. And then we're going to compile the contract. So click on compile one_storage.so. Okay, so actually it was auto compile, so it's already done, but just for safety, we are double clicking it just to make sure. Okay, so once it's finished loading, it's done, we can move on to the next tab for deployment. Okay, so again, it's easy to get lost in this process. So if I'm moving too fast, or if you're confused at any point, make sure to put something in the public chat so that I know I should clarify. Okay, so the next tab, let's go to the deploy and run transactions. We don't have to do any changes here. We just have to directly go to deploy. Okay, so deploy, you should see that there's some movement on the page. Right here in the console, it should have a green check mark that shows that the contract is already deployed. Okay, so this is a transaction that is sent to the blockchain, and its status say that it is true, the execution has succeeded. So what we have done just now by clicking the deploy button is we have already sent the contract onto the virtual machine blockchain. So now we can interact with the contract so if you, from where you deploy it, if you scroll down, you can see all the contracts that you have deployed. So here is the contract that we have just deployed, which is called storage, right? So the contract name was storage, and it will also show up here, right here. And then we can play around with it. So we can store a number into the contract. So say I want to store what is today's date, 420, right? April 20th. So let's store it. Okay, in reality, blockchain actually transaction doesn't happen that fast, but since we're working with a virtual machine, it's like a split second that it's done, right? So you can see that like right in a split second, it's like, okay, confirmed. So again, when we see the green tick again, that means what we have just done is completed. Well, how do I know it's completed? Because there is another function that is called retrieve. So the number that I just stored, which is 420, I can now press the retrieve button, which essentially called the retrieve function in the smart contract to get what I just stored. So you can see the output right here. Let me zoom in even a little more. Right here, 420, right? So I get back what I just stored. I can store another number like 42. 1, 2, 3, 4. Right? And then when I retrieve it again, I will get my new number. So this is the simplest ever contract that you can get on a Solidity. So that would be our Hello World exercise, just to get a little bit feel on how to deploy a contract and then interact with a contract. Okay, so that's the basic functionality that you need to get to know on the Remix IDE. Then right now we're going to switch gear a little bit back to talking about the key features of Solidity that you need to know before we proceed to create an NFT contract. Okay, so Solidity 101. Really, if you are a programmer in more of the C family language or Java, a little bit of the low level meaning it's a little bit closer to machine code, you might be very familiar with it. But if you are a programmer in Python specifically, so I know a lot of people start with Python, you have to pay attention to a lot of the little details in Solidity, because there is a lot of declaration that we have to do. Unlike in Python, we can just declare things on the fly. That's not true for Solidity. Okay, so for Solidity, the first thing that you need to know is some important data types. Okay, this is by no means a comprehensive list. The comprehensive list, which I'm going to send out that you can read, is right here. So I've just put it in the chat box again. So this is a list that you can find. Sorry, this is variables. Okay, wrong link. Let me find the. Right here. Okay, the variables is for another time. Anyways, so data types on Solidity. This is not all the data types, as I said. You can see that in the link I just sent. There will be a lot more, but these are some important data types that, number one, we will see it in our NFT contract. Number two, some are unique to Solidity. And number three, well, they are important. Okay, so let's start with the first thing, which is the address. So just a show of hand, or you know, to use the Zoom reaction function, how many people actually own a crypto wallet in any form? Could be in a central exchange, could be in a MetaMask, just so that I know how to explain this a little bit better. Okay, that's not bad. I think around 7 or 8 people. Okay, so in that case, let me demonstrate a little bit with my own wallet. Let's see. In that case, I need to share my whole screen. Just give me a second. So this is a kind of what we will call a smart wallet, or a wallet that can hold all the cryptocurrencies like Ethereum, well, not Bitcoin, Ethereum and any other Ethereum-like chains tokens. So you can see that here. I can't really zoom in on this, so I'm sorry, but you can see that right here, there is a wallet address that is related to the my account. Okay, so this is my identity number. This is a hex address that starts with 0x and then followed by 42 hex characters. So essentially, everyone in the network, every wallet in the network, every smart contract in the network is being identified with this address. Okay, so address in Solidity is a specific format of data type. It is its own data type. So you have to pay attention to not to be confused with other numbers that might look pretty much like an address. Okay, so that's the first thing that we need to pay attention to. The second type of important data type is integer, of course, because most of the things that is happening on the smart chain would be usually integer rather than a decimal number. So integer, usually we will just use integer, integer 256, which just means that it's an unsigned integer, so non-negative integer with a size up to 256 bits, right? So 2 to the power of 256. Okay, and then we have almost the equivalent of integer 256, which is bytes 32. So it's a sequence of 32 bytes. You can think of it as the bytes is just the uint in hexadecimal form. Okay, so for example, let me show you. Okay, so for example, the number 1, 2, 3, 4, 5 in integer will be converted to 0x3039 in bytes 32, right? So just a hexadecimal form. Okay, that's simply the difference, but their size is exactly the same. And then last but not least, we have something called a mapping. So mapping is sort of like a dictionary in a lot of other language that we know, except a mapping is a dictionary or a hash table that maps every single possible values to a value. Okay, so again, it will be a little bit confusing without a demo, so we will demonstrate it in a little example. Okay, so to understand how to use these data types, we're going to create the simplest smart contract to contain all these 4 types of data types. Okay, it will be a non-functional contract, meaning that it doesn't really do anything other than the fact that it is going to store these 4 different things. Okay, so to make it a little bit easier as we are coding, I'm going to use a tool that is called CodePile. Okay, so let me share the link first. Okay, so this is a tool that I can just type anything, and you should see what I'm typing in real time. So hello, everyone. Okay, I've disabled editing on your side just because I don't want it to get too messy, but otherwise it should be pretty nice. Let me just switch back to, so unfortunately they don't have Solidity here, so I'm just going to use the closest equivalent, which is JavaScript. And then just for everyone's reference, I'm going to put the links that I have put down so far here. Okay, so right now, let's start with our very first contract that we will be doing starting off today. So we will be, let me leave some blanks. So we will be starting off our contract with a license identifier. This is usually recommended by Remix that we do it. And then I'm going to start off with defining a pragma that just tells the compiler which version of Solidity to use. So the latest one is 0.8. So that's why we're using 0.8. And then I'm going to start defining my contract that is called data types. So this is just a first contract that we'll build today. It's not the actual NFT contract. Okay, and then with that, I'm going to do 4 types of data types that we will practice. So the first one is address. Second one is integer 256. Okay, for those of you who don't use JavaScript normally, the double slash is the commenting symbol for JavaScript, right? So everything with a double slash is invisible. It's just a comment for us. Okay, so 4 types of data type, and then we will learn how to declare each of them. So for address, how you can declare it is to, well, start off with your identifier. So address. We are going to tell the program to make this variable public for an obvious reason that we'll see in a bit. Okay, and then I'm going to call my address just variable just n with a big A. Right, so it will be the format is data type and then public or private and then variable name and then equals the value. Okay, just an example. This is my testing account. You don't have to use this address. You can just copy it over on yours. That's fine. I don't have any money in this, so don't worry about it. Okay, so this is the format, right? So basically what I've done is I've declared this to be the value of this variable, big A address. Okay, likewise for integer 256, I can call it just the integer and I can make it, well, so now it has to be an integer, right? I can't declare it to something that is not an integer. So let's say 1, 2, 3, 4, 5. Yeah, so feel free to copy and don't mind it being all highlighted in. I think everyone can understand. Okay, so then I've defined my integer variable to be 1, 2, 3, 4, 5. Next up, I'm going to define a data type that is a byte 32. With, I was just going to call it bytes. Okay, and for bytes 32, it has to be something that start with 0x. So let's say 0x. It's just a random, this is a huge number that is random. Okay, so all these 3 types are just like any variables that we're used to, nothing special. The most interesting property that we get in Solidity is actually mapping. I think mapping is one of my favorite data type because it's so helpful and useful. So the format, okay, so the syntax for mapping is data type 1 to data type 2. Okay, so a mapping from one data type to another data type. This is very useful because these 2 data type can be pretty much anything. So it could be a mapping from address to Boolean. Okay, what does that mean? What does that mean for a address from Boolean? Let me declare it first. So this is address to Boolean. Okay, what it means is, What that means is it is just a hash table that maps every possible address to true or false. What would it be useful for? It could be useful for whitelisting, right? NFT, when we buy an NFT or when we sell an NFT, some NFT projects say that, well, you need to come to our server to chat and get a whitelist, right? Otherwise, you can't buy our NFT. Well, how do you manage a whitelist? Well, we can do a mapping. If it's true, that means the person is on the whitelist. If it's false, that means the person is not on the whitelist, right? And that exists, this mapping exists for every single address in the world. That's why mapping is so helpful, because it doesn't matter who you are selling it to or who enters your program, they will always have, like, it will not throw an error. There will always be a correct mapping that corresponds to that address. And for default, for mapping, there is always a default value. So in this case, the default for Boolean is false. Okay, so that means that everyone in this world, when we just declare it, their address will be mapped to false using our mapping. And other mapping we could do is something that maps, say, a bytes 32 to a integer. Okay, so bytes to int. Well, this will be a mapping from every possible bytes 32 value to a new integer, right? And the default value is 0. Well, how do I know all these default value? It's actually all in the link that I sent you about the data types. So there's a lot of different defaults when you don't declare something to have a value. So you can actually check. But I'm just here using the most common two types of mappings, which is mapping to Boolean or mapping to integer. So the default here is important, right? It's the default false or the default 0. Okay, so without us realizing, this is actually already a contract. So let me copy this whole contract to our Remix IDE. And then I'm going to open a new contract here. So open a new contract with a blank page here. And then I'm just going to call it data types.sol. And then I'm going to paste it in the editor. Okay, so just paste everything from the license all the way up to the end of the contract. So once I paste that, I can compile my contract and I can actually see, so compile it in the middle using this icon and then go to the next icon and deploy it. And then I should see my data type contract, which is the second one here, right? Because I already deployed the storage. So the storage is the first one, the data type right here is the second one. So by making things public, I can actually see it when I interact with the contract on the blockchain. So if I click on the address, it's going to give me the exact same address that I stored here. Right? If I click on the integer, it's going to show me 1, 2, 3, 4, 5, which is exactly the integer that we stored in our contract. And also, if I click on bytes, it's going to show me exactly where bytes, what my bytes 32 that I saved is. Okay, for the mapping, I need to actually give it an input. So what I'm going to do is I'm just going to, let's say, put my own address in. You can also put the dummy address that we have here. And then I'm just gonna see what it gives me. So if I put in my own address as the input of the mapping, it's going to show up as false, right? Because I told you mapping to Boolean by default is false. Okay, so it doesn't matter. I can even enter any address and it will still give me there will be an output. So that's the property of mapping. Okay, so make sure if you have any question, put it in the chat, because I know we're moving a little bit fast, but it will actually even get faster because we're a little behind on schedule right now. So hopefully we can get to at least have something meaningful in your NFT contract today. Okay, so quickly moving on. Okay, these are kind of info that you should know. In reality, when you're working with it, you just sort of understand eventually. So we're not going to have examples, but 3 types of variables. State variables are the things that are stored on blockchain. So that means that it is what we have declared all on the data types contract just now. Those are state variables. Okay, local variable, also very common to any other programming language, right? It's inside the function and it's present only when the function is executing. Okay, global variable, however, is something that is a little bit more interesting. So let me copy this again. Okay, so this is where the link that I sent wrong will come in. So I also put the link in the public chat. So global variables are this table right here. Okay, so it will be very specific to the blockchain. It will be something like the block difficulty. So that is more on the blockchain technology, which we'll not cover today, but it's properties of the block. You can think of it. So timestamp, guess left, etc., etc. A lot of the global variable where you can just call in your program without declaration, and you will get a value. So these are the global variables that is unique to blockchain or to Solidity. We will use some of them in the NFT contract, but not all of them. So I will explain when we get there. But you just have to know that this exists that you can call as global variables. Okay, and then there are also some different types of functions. So by default, if you don't say anything about the function, if you just call the function, it is by default to assume to be something that will alter the data on the blockchain. But there are also 2 types of other functions that will be cheaper. What do I mean by cheaper is that if you haven't interacted with the blockchain before, every transaction that you have to interact with the blockchain, usually there is a gas fee that you have to pay. Okay? The more data that you are changing on the blockchain, the more expensive your transaction gets to be. However, if you only need to see the data on the blockchain, it is much cheaper or sometimes even free. And that's where the other 2 types of the functions comes to be, where you can view the data or even just do something that is not related to the data at all. Right? So the second type and the third type, the view and the pure functions, are the cheapest. You don't have to pay any gas fee to use it. So those are the 3 types of functions on Solidity. And again, there will be at least 2 types, I think, that we will use in our NFT contract. Okay, so let's move on to create an NFT. Before we talk about creating an NFT, well, what is an NFT really? Like, is it something that is special, that is, like, why is it so special? But really, it's only a specific type of token contract on the blockchain that satisfies the property of it being unique and indivisible. So what does it mean by indivisible? It means like, I can't sell you 0.5 an NFT. Right? If I buy a NFT, say from Bored Ape Yacht Club, it's that monkey, the monkey avatar. Well, I can't say well, let me sell you half of it. So that's not possible. So that's one property that it has. So there are several standard contracts that people use on Ethereum today for implementing the NFT. Okay, so NFT is just a broad name of a family of contracts that satisfy certain properties or requirements. Today, we'll use the easiest one, which is called the ERC 721 token standard. So let me send you a link on what the token standard is. So we have luckily, because this is something that everyone does, we have websites that already have a sample of how the contract will look like. Okay, so I put a link in the public chat just now. You can take a look. So this is kind of what people have built as an open source resources for you to just copy over and make your NFT contract very quickly. So specifically, right here under usage, so don't need to click on any other page, just under usage, they already gave us the simplest contract. Okay, so if I copy this into Remix, so let me start a new contract again. Okay, so start a new contract. Let me call it my NFT.sol. Okay, so my NFT.sol, and let me just copy exactly this into my remix. Okay, I'm also going to copy it into CodePal just for your reference. Okay. So if I just copy that into Remix and then just deploy it, right, so if I just copy this ERC 721 contract into my remix, okay, and I then compile and deploy it, compile and then deploy my contract. So when you're deploying the contract, be careful. So if you click on this drop-down menu in the contract right here, so this is where you need to pay extra attention. Make sure that you are deploying the one that is the one that you named. Okay, we'll talk about why there are so many in a bit, but just to remember that, well, we call it my NFT, right? So then you should deploy the one that is actually written by you, which is my NFT. Okay, so deploy my NFT. And then voila, yay, we have our NFT contract and we're done for today, bye. Okay, of course, it's not example as easy as this, otherwise we will not have done all the preparation work before. Okay, so, but this is the base or the skeleton of a NFT contract. It has all the basic functionality of NFT contract because we have, even though it's so short, we have embedded what the template has already given us. What do I mean? Look at the left-hand side of my NFT contract. There are so many functions that we have that we didn't declare, right? We didn't write in our program. How come there are so many? Well, it is because these are functions that already exist in ERC 721. Okay, this property that we're using here is called inheritance. Okay, so inheritance means that we are using someone else's contract and we include it in our own, so that we inherit all the functions that they already have in the original one. In this case, we are inheriting the ERC721 contract. So even if my contract has absolutely nothing inside, actually it already has a lot of functions available to us. So that's the first thing that we need to learn about kind of what is happening in this NFT contract. The next thing that I want to pay attention to is the constructor. Okay, so if you look at the basic contract that we just copied over, there's something called a constructor. The constructor is a special function that gets executed at exactly once when the contract is created. So that means that if there's something that you want to declare when your contract first get deployed, you can put it here. In this case, there is something that is done in the constructor, which is it actually says something like my NFT and MNFT. What that means is, so let me go to our code pile and comment out. So what that means is right here, this is the token or the contract name, or you can think of it as the NFT collection name. Okay. And then the token symbol. Token symbol is just like how Bitcoin has the symbol BTC. Ethereum has a symbol, Ether has a symbol ETH. Okay, so in this case, even NFT has a token symbol. Okay, NFT, you have to give a token symbol to it. For our purpose today, we'll just keep it as it is. Okay, and then the next thing that we will need to learn to use is we need to extend the function of this NFT contract. Okay, so first thing that we need to do is we need to create a counter. Sorry, we need to inherit something that is not the ERC721. In fact, we're going to inherit this contract instead. Okay. So now instead of inheriting ERC721, I'm going to inherit ERC721 URI storage. Well, what is a URI? For every NFT online, normally, actually, there is a underlying metadata file that looks like this. Okay, this is an NFT. Actually, NFT is not the image. It's not the. It's not whatever the video. Actually, usually what is actually getting sold is the metadata. Okay, so this is the simplest metadata you can have, which is just a name, a description, and the link to an image. Okay, so we need somewhere to store this. That's why this is called a URI. So that's why we will have our contract to use URI storage instead. Okay, so that's the first step that we're going to do today. And then the next thing that we're going to modify is that we need to have an ID for every NFT that we create. What do I mean an ID is, let's say if I now mint my first NFT, it should have an ID of 1. And then the next person who buy an NFT from this same contract, well, the contract should create an ID of number 2, number 3, number 4, incrementing. Right? So we need an ID for each of the token. To implement something like a incremental counter on blockchain, again, there's something we can use. Okay, which is counters.sol. So very luckily, again, there are some open source tools that we can use. So counters.sol, that just means that it will help us implement the counter capability. So the way, if I want to do so, is I can say, let me use counters for counters.counter. Okay, so I'm asking my contract to please learn to use this function counters. And then I will have a special data type, which is private, because I don't need okay, very good question, but let me finish this part first. So actually, it's not true that importing need more guests, because essentially what is happening is your contract is copying the content of what you're importing into the head. So it's just like including in other programming language. What it is doing is it's copy and pasting all that you have imported into the contract. So I don't think it actually need more guests, but if you have functionalities that you don't need, but you're importing so many functionalities that you don't need, that might be a waste of gas when you deploy it. But in this case, just yeah, it wouldn't make a difference if you just copy it over versus if you import it, if that makes sense. Okay, so step 2, it's to create something called a token ID. So what this token ID is going to do is it's going to increment from 1 to 2 to 3 to 4 to 5 every time there's something that happens in the there's a new token that is getting created. Okay, so that will be the preparation work. Now let's actually get to work. The first thing that we will need is a function to mint. So minting means creating a token from thin air. Okay, so that is what mint means. So this is just a terminology that is from actual financial systems. When we make a coin, like an actual metal coin, the verb is called mint. So I'm going to create a mint function that takes in 2 parameters. First of all, is an address that I send it to. And then the second of all is a link to my token URI. So the link to my JSON file here. Okay, and then I'm going to set it to return a integer, which is just the token ID when it's done minting. Okay, and then inside there's basically 5 steps that I need to do. I need to first ask the token ID to increment. Right, so add 1 at a time. And then I also need to ask it to I need to save the current token ID to a new variable. Okay, so I need to declare it so that it saves to a new variable. So this is the current token ID. So let's say if I'm minting the first one, this will be 1. If I'm minting the second one, this will be 2. And then I am going to mint my token. Okay, so this is a function. This is a function from ERC721 URI storage. And then also, I need to set my token URI to what I inputted. So I need to save this JSON, the link to this JSON, onto my contract. So it's by setting it to be my token URI. Okay, so this is also from this is also from ERC URI storage. Okay, and then last but not least, I need to return new token ID. Okay, so now that is basically a functionality complete, feature complete product. Okay, we can mint by putting in an address and then the token URI. In fact, we can try it very quickly. So let me just do that very quickly. If you can follow, you can skip because we will deploy the actual one again in a bit. Okay, so let me, did I spell something wrong? Oh, right, sorry, public. Okay, so let me compile and then deploy. And then now I have a mint function. So I can mint to my address, and then I will be putting this link into the token URI. Okay, so that will be a sort of feature complete product, except you would like to add a little bit more functionality to it. Okay, so there is something that I would like to do, at least just to show, let's say, well, what else can we do, right? For example, we can, well, make someone to pay us if they want to mint an NFT. Okay, how do I make that happen? I can say that, hey, please pay. I can make the mint function something called payable. Okay, payable. And then I can specify that I want the contract to collect a mint price. So public mint price, say 1 Ether divided by 1,000. So 0.001 Ether. Okay. So now I can, well, not just that, I also need to make sure that they are paying me, right? Just to make the function payable. So making a function payable just means that it can receive funds, okay? But I haven't checked that the person actually pays me the mint price. I need to add a require statement. Okay, require statement that asks the system to check whether the person has indeed sent me the mint price. Okay, so check that the transaction carry enough value for the mint price. Okay, so that's one functionality. One more thing that we can do just for today. So actually the contract I have on GIST have much more functionality. So I wish you can also study that when I send it out. But today, one more thing that I need to do is, well, if I get people to pay for minting a function, that value is actually paid to send money to the smart contract, not to me. So what I have to do is I have to make sure that I am able to withdraw the money. In order to do that, there's several things you need to do. First of all, you need to declare yourself as the contract owner. If you just put a contract onto this blockchain, it doesn't mean automatically that you are the owner of the contract, unless you specify. Okay, otherwise, everyone in this world can interact with any of the functions you have on this contract. So to do that, we have to declare something called a owner. So address, public, and then owner. Okay, and then when we deploy the contract, what you can do is you can make the owner to be the message sender. Okay, so making the owner to be the contract creator or deployer. Okay, so that's that. So now I can actually withdraw my fund. Once people paid me to mint an NFT, I can withdraw. Okay, so withdraw. I can make sure that only the person who is the owner can withdraw. Okay. Only owner can withdraw. So the require function means that you have to require this, and then this will be the error message that gets sent out. And then after the require function, then I can ask my contract to pay out to me. Okay, so that just means send all the funds in this contract to the owner. Let me check if I'm missing. I think I'm missing some semicolon here and there. I think it should be fine. Let me try to copy this over. So I know I went through the last bit pretty quickly. So is there any question? I mean, I also don't mind to stay a little bit after the workshop ends if there is really questions that people want to. Okay, so I misspelled public. That's one thing. Any other errors that I've made? Oh, I've misspelled owner here. Okay, cool. So let me change that too. Yeah, so that's why it's actually very good for Remix because it just directly spots your errors. Okay, so that now is a better contract. What we can implement even further is a whitelist. So in the GIST that I will send out in a bit, there is actually a whitelist function in the contract as well. So that is a real featureful function that we didn't get to, a real featureful NFT contract that we didn't get to cover all today. But this is pretty much good enough as a public sale NFT. Okay, so let me demonstrate to you that this will be a contract that is actually working. What I will do is I will compile it. Okay, this time instead of deploying it to my to the virtual machine, I am going to use my own wallet to deploy it to the testnet. Okay, so testnet just means that it's some network that the token is pretty much free to obtain. Okay, so I don't actually have one Ethereum in this wallet. This is testnet token. So let me try to deploy this in my testnet token. And then I'm going to deploy the contract. Let me show you the process, actually. Okay, so if I deploy, my MetaMask will come up. I actually have to pay gas fee to deploy. So this is what your HP was asking about, gas fee. So it's still pretty cheap. Well, of course, this is not real Ethereum, so it's not bad for me. But if it's real Ethereum, right, then you have to be careful. So now I'm going to deploy this contract onto the Winkerbee Test Network. Okay, it takes a while to confirm. So this is the difference between the virtual machine and the the actual network, but it's still pretty quick. So now you can see that on the network, this is actually on the testnet blockchain already. It's still being confirmed, I believe, but so it's already created. It has a contract address, and it shows that it's a contract creation. Right, so it's as easy as that. So now it's completed. I can even see my gas fee. So it's also a contract that everyone in the world can see right now. Okay, and then I can interact with it on here. So I can mint an NFT to myself right now. I'll put in my address. Okay, and then I'm going to put this link right here, the link to my token URI right here. So the JSON file. Okay, so let me, what will happen is that it will show up in OpenSea. So OpenSea is one of the biggest NFT marketplace in the world. You can see any NFT that is not even created by yourself. This is not from today. So let me hide it for now. Okay. So let's say I don't have any NFT in my wallet right now. And as soon as I mint one to myself, it should show up in my OpenSea. So let me try. So minting and then sending to it. Well, remember, I have to pay 0.01 Ether, which I have to convert because I don't know how much that is. So 0.0. Okay, that would mean 1 million Gwei. Okay, 1 million. Okay, if I don't put a value here, I actually can't mint. So this is me paying to the contract. So let me try now. Okay, so you can see 0.001 Ether I'm paying to the contract. I also have to pay gas fee, and then I can confirm. So now it's minting. Minting should take a little longer than contract creation, but let's see. Okay, done. So now I've minted my first NFT in this simple contract on testnet. And if I okay, let's see if this is the new one. Let's see, hold on a second. I don't think this is the new one yet. Just give it a. Oh, right, no, this is the new one. Yep. So the contract ends, as a minute ago. Okay, cool. So now I'm seeing that my freshly minted NFT on OpenSea. Okay, so this is kind of how you would create an NFT contract. As I said, there is actually a lot more functionality that you can add to your contract, which I will include in a GIST that I'm sending to all of you right now. Actually, at the end of the workshop, just because I have to fix some formatting issues. But other than that, that is kind of what we'll cover in terms of technical details. But we really want to cover the next part, and we'll hope you will stay with us the next part, because it will be something that will be very beneficial for you if you want to go further in Web3 development. So really, as you can see, I'm the representative of CKU today. So of course, we really hope that this is a workshop that will bring your interest to Solidity programming, and then you can come join us at our CKU program. So CKU in this tweet, as you can see, is free online course. Well, we said for experienced Web3 builders, but if you are already proficient in other programming language, we're pretty sure that you can join with and follow with no problem. And we are really trying to promote products with zero knowledge. Well, what is zero knowledge? We'll talk about it in a bit. And then most important bits that we want to share with you is a learn to earn course. So the learn to earn course means that as you complete the course requirement, we're actually going to pay you back. Okay, so if you can pull through the whole entire course, we'll pay you back. And we'll talk a little bit details about how can you receive the $3,000. And this is in US, by the way, because I know we're in Hong Kong, but these are all in US dollars. And then there is also an opportunity for you to earn a recurrent passive income up to 15K US per year. And we'll also talk about, well, how can you get that 15K per year passive income? Well, first, let's talk about what is zero knowledge, or ZK. Okay, so zero knowledge proof is a method that you cryptographically prove that from one party to another that you possess knowledge about something without revealing the underlying information. Okay, this is a little bit abstract. So what I've prepared for you today is to use a very concrete example. Okay, so this is two jars, which is one red and one green. Actually, let me maybe turn off my virtual background so that you can see. Okay, right, one red and one green. So the idea is, let's say my supervisor is colorblind, and he can't tell that these two are of different colors. Well, what happened is that I want to prove to him that these two are different colors without telling him that, okay, this is green and this is red, because I don't want to reveal that information. What I can ask him to do then is I will hand him the two jars, right? Left hand and right hand. And then I will ask him to swap them behind his back, right? And then show me again. Then I will tell him, I will show to him that I know these two jars is different because I will be able to tell whether they are swapped or not, right? So whether this is, so let's say this, my left hand is with red right now and the right hand is with green. If swapped, I will be able to tell. The person with color blindness wouldn't, but I will be, right? So if this game happens for 1,000 times, 10,000 times, and if I get up to 100% accuracy, which I will, right? Because I possess the color knowledge, well, then it should be convincing enough for the person to believe me that these two are of different colors, even though he still doesn't know what color are them, right? But they will believe me that this is of different color. So this is the essence of zero knowledge proof. Of course, I wouldn't go into the mathematical property of it because that will be something they will learn in the course. But we hope that this will be something kind of interesting enough for you to get into this. Well, of course, it was a very high level description, but what is this whole zero knowledge technology actually is useful for? If you don't know yet, all things on the blockchain is transparent. That meaning that you don't know, even though you don't know who the person is because it's just an address, everything is still seen on the network, right? Just like how I just deployed a contract onto the testnet, essentially everyone in this world can see. And everyone in this world can see that it's from my address. Okay, so what zero knowledge can do to blockchain is to add privacy. So there are several ways that it can add privacy, including pretty much scaling blockchain by aggregating transactions, or it can shield your transfer, right? So if I am transferring to 1 ETH to Justin, there's actually a way to shield it so that people don't know it's me transferring to him. Okay, and there's also other purpose like authentication, and also if we're holding a vote on the blockchain, there's a way to avoid collusion. So these are all kind of useful applications of what zero knowledge proof can do on blockchain. And so it's more than just the game that I talked about. And that's also what we will be. And these 4 applications are all the things that we will be talking about in the course. So right now is probably a good time to introduce my PhD supervisor and also actually the organizer of Zero Knowledge University. So he is the core team member of Harmony Chain, which is, I think, around the top 50 or 60 blockchain nowadays. And he was a professor who has pretty much moved into the Web3 space. So I'll leave it to him to tell you about why this course will be so exciting and how you can get into this course and what will be, like, what is the process of this course looks like.
Thank you. Yeah, all right. I think I can you hear me now? Yeah. Hi, so my name is Hakwan. So yeah, where do I start? First of all, thanks, Kathy. It's such a great course. Always such a treat to hear you teach. And one of the reasons I'm no longer a professor is because Kathy has been so good that I should just stop teaching from here. Even though we did some research together, which meant she was doing her PhD while I was in the same lab, but she really killed it. And so thank you, Dr. So. And so if you are hoping to get this, quality education for free instead of paying school fees, CKU would be a good place for you. Maybe I can say a bit about my background. As Kathy pointed out, although I was her kind of PhD advisor, I'm not a computer scientist. I'm a cognitive neuroscientist. I study the human brain for a living. So a lot of what I do isn't nearly as technical. I had a bit of a background in machine learning and a bit of background in this sort of stuff. But I can tell you the reason I'm involved in Harmony, in fact, that might be a good start to say, it is all because of a kind of random luck or connection. So the founder of Harmony, and actually a lot of people didn't know, Harmony is a company based in the Bay Area in San Francisco. We're in Palo Alto, Mountain View. But the founder actually is from Hong Kong, Stephen, and he was actually my middle school best friend. So back in the early 90s, we actually learned how to code together as middle school students, and that's how I got into crypto actually. So it wasn't for the money, it wasn't for the growth, but I also come to appreciate how ridiculous the growth has been in the past few years. Like last year alone, I think Harmony have seen a 70 times 7x, sorry, 70x, so 70 times full growth. And we are not even the biggest chain. I mean, we are one of the, in a way, smaller layer one chains. So you can think of us as like a bonsai plant version, like is like a pungang version of what ETH 2.0 is supposed to be. So Ethereum has been, of course, the biggest smart contract chain, and most of you would be studying it if you come into this space. And they have been trying to upgrade themselves because the chain has gotten so big that it got so congested. And so we have been basically doing what they are planning to do since 2018. So we use a technique called sharding, and we've been like basically building a much faster, cheaper, greener, more scalable version of the current proof of stake network. So why am I involved? I mean, given I'm not even a neuroscientist, I'm really involved for the pedagogical side. So I'm a teacher. I used to be a professor, and I think I know how to run universities and university level courses. But that wasn't the reason why I got into this. Obviously, I left the university because I don't want to teach so much anymore, because they're better teachers like Kathy. But I think what really got me into it was the fact that now they have gotten so much money in this field, and the economics is really interesting. So I think in crypto, there is a sense that none of us make any profit. It might sound like a crazy thing, but what I mean is the cryptocurrency system is set up such that like our Harmony chain is a one coin, right? So the one, when I said that we have increased like 70-fold, I mean, the one coin has increased 70-fold in value. Some people increase more, like if you ask Luna, Solana, they increase over 100-fold. But for the chains that do well, that they are reasonably good chains, we've seen a huge amount of gain. And so I think the market cap at this point for Harmony is over $1 billion. That is like what in Cantonese we'll say 100 億. When I have to explain to my parents, it's like these are surreal numbers. These are unrealistic numbers. And make no mistake, I mean, we understand that the market will go up and down, right? So it's not the money will always be here. And so my role at Harmony has been to try to take this money and, in a sense, invest it back into the community, because we think that for technology this new, the community ultimately is all there is. The markets will go up and down. When we have a profit, we should take it and reinvest it back into the community. And in fact, this is not because we are like a philanthropy. We are not like a Xintong. We're not like a charity. But this is a way of thinking the business, is that the people is where the value is. And it's the same in Ethereum, which is the biggest chain. That's why we go to Ethereum meetings and see what they have the best developers, and how much are we willing to pay to get the best developers too. And then immediately people think, oh, should we headhunt the developers? But it doesn't not work like that for us. For Harmony, as a chain that built the infrastructure from the ground up, I think our approach is really to get people in, and also get people in not in a way to lock them up in a situation in an employment contract. So you can talk to Kathy about it. So Kathy is a mentor at CKU, and we generally try not to think of it as an employment relationship. We just pay people money and hope that they would do well. They would do what they're supposed to do. If they don't, that's fine. And we usually don't go about micromanaging people. And I think that kind of resonate with me a lot as an academic. This is also what academics want, right? Academic freedom. Just pay me the money, I'll do the research. But don't try to tell me exactly what to do, what not to say, what not to do, because this is how you actually have a community of people who really feel that they belong to the community. They are not just here to earn a buck. And this is what we really build up as the philosophy of CKU. So that explains like why we're paying you money. It's not like we're paying you money. In a way, it's kind of like a scholarship, right? So scholarship, you can also get paid up to 2萬蚊港紙, like $3,000 for 2 months. It's a good scholarship. but it's not like ridiculously generous. But I think the difference is for scholarship, we're trying to look at your CV, your background, your GPA, and try to give the scholarship to the people who are most outstanding. And we don't want to do that because in Web3, the whole idea is we don't care about where you are. In fact, you can be anything. You can be not graduating. You have a GPA of 1. Or you can be dropouts. But so long as you can do the work, we should be able to reward you. And likewise, this is also why I can now do a little bit of doxing. So people like Kathy is now being paid like $75 per hour, US dollar per hour. And this is our hourly rate, which again, you might think like, this is a little bit bizarre. Why do you need to pay people that much, right? Because my teaching assistants at Hong Kong U were not paid that much. My teaching assistants at UCLA were not paid that much. But again, the idea is, well, if in the Bay Area, we are thinking about hiring a good engineer, $75 at least how much you have to pay. And just because you guys are not in the Bay Area does not mean anything to us. We should just pay you how much these things are worth. We should not be paying you. Depends on how much we can get away with not paying you. So that was that like whole philosophy in there. So it feels a little bit like more egalitarian, which is why I'm involved. And I should stop maybe just, ranting on because as I explained, I'm a bad teacher. So let me just finish with one point before Kathy would cut me off. That is, so the course itself is a 2-month course. You do assignments, and then for each assignment that you submit on time and satisfactorily, you earn, I think, a couple of $100. And then you can be helpful to other students and you earn some extra money. You can do outstanding assignments. You can earn a bit of extra money, like $100 US dollars, all I'm talking about. And then by the end, if you launch your final project and you graduate, you can claim all the money that you've earned over the course. And the most exciting part all depends on launching your final product. So the whole course was set up. That's why we are skipping all the math that is not necessary to just get you to the point you can launch a product. It can be a great, crazy product. It's completely original that would change the world. That would be great. But even if the minimum, it has to be a product with a meaningful zero knowledge use case. And once you do that, we will invite you to join our DAO, which is basically our board, if you like. And then that oversees the entire treasury. And we are expecting by the end of, maybe not by the end, but by sometime in Q3, by sometime around the summer, we should have about, we will have over 10 million US dollars in our treasury. So in Hong Kong money terms, we will be guoyik by sometime in the summer or autumn. So you will be part of the whole decentralized group that will manage this money. And that money, in turn, just by the interest rate, should be able to pay you a basic income. That is like, think of it as a sangguogam, but you don't have to be old to get it. Everyone can get it, and it depends on how well your project launch is doing. So you can basically quite easily earn up to $9,000 per year, and it will be a lifetime, basic income as long as our DAO survives. And I can tell you, I don't intend for the DAO to not survive because all our coins are not even in. We'll invest it very conservatively to make sure it survives. So we really want to do that, and people again will think it's a bit crazy, and that's why I gave my long opening about why we're doing this, because the idea is if you're a good developer and if you're building something on our platform, we want to just keep you happy and pay you money. So it's not like you should stop there, but it's just like with that money you can do whatever. You can just build anything you want. Yeah. So that's my introduction of the course. Go to the website for more details. And I think most importantly, bring all your friends. So we are really scaling up and there's no competition in this space. So don't worry about that at all. Spread the words for us, bring everyone. We are getting ready for a really large party in May.
I see. So thank you, Kathy. Thank you, Dr. Lau. So thank you everyone for joining us to this workshop today. And I hope you learn a lot more about smart contract, NFT, and the mechanism of the coming ZKU cohort. And we hope to hope you to join the next cohort to gain more experience and insights in the civil knowledge proof industry, and see you soon in the next event. And I will open the Q&A sessions if that's necessary from the audiences.
I think we got a question from HP about, do you have knowledge in Go? So Go and Rust are not, well, they're not directly, well, Rust are languages on some blockchain, right? Like Terra and Solana. And then for Go and Rust, the other significance of those languages is to actually interact with the blockchain in a more efficient way. So there's actually a lot of ways that you can set up a backend to interact with blockchain, but for example, in JavaScript. But it's just in general, people have found that in more low-level language like Go and Rust, it has been more efficient. And that's actually a lot of what the bridges and all of the infrastructure architecture in the blockchain is using. It doesn't have to be the questions about the course. It could be the questions about earlier content as well. I realized we didn't have a Q&A part for that part. Or it can even be question be like, oh, how is it like working for in Web3? You know, it could be just really anything, because I know a lot of us is new to the Web3 space. Anything except investment advice.
I think, yeah, if people are not really eager to ask questions now, we can also join the Discord servers of both SecKU and the Blockchain HKU. So yeah, so keep your questions in your mind, and then you can ask the questions later in the Discord servers. So I will end the Zoom meeting now, and yeah, thank you all for joining today.
Thank you. Spread the word.